Today, we're diving into a paper that takes a really deep puzzle in quantum physics, and, it doesn't just try to solve it, it tries to make the puzzle itself just disappear. So, how does it do that? Well, by proposing a totally radical, geometric reinterpretation of time itself.
All right, let's just start with the question that really haunts quantum mechanics. Can the future influence the past? I know it sounds like pure science fiction, but some of the things we see at the quantum level are so strange, so weird, that physicists have actually developed serious, legitimate models where this might be happening.
So, here's how we're going to break this all down. First, we'll get a handle on this retrocausality puzzle. Then we're going to introduce a completely new way of thinking about time and see how it makes that whole mystery kind of dissolve. After that, we'll apply this new lens to some existing models before we tackle the biggest question of them all. Is time even real?
Okay, first up, the retrocausality puzzle. To really get why anyone would propose such a wild new idea about time, we first have to understand the problem they're trying to fix.
At its absolute core, retrocausality is the idea that an event in the future could literally be the cause of something that already happened. It's a concept that takes our everyday, common-sense idea of cause and effect and flips it completely on its head.
And look, this isn't some fringe idea cooked up in a basement. As the paper points out, there are whole families of scientific models built on this. You've got statistical models, wave mechanical ones, even computational models. But they all share one critical assumption. They all start by assuming time is real, and then they try to figure out how causation can travel backward through it. But the paper we're looking at today, it takes a totally different road. Instead of trying to explain backward causation, it asks a much more fundamental question. What if our entire concept of time is just wrong?
This quote from the paper really gets right to the heart of the whole thing. The argument is simple, but it's incredibly profound. If time isn't a fundamental piece of reality, then there's no real forward or backward direction for anything to violate in the first place. The problem of retrocausality might not be a problem we need to solve at all.
And this brings us to the paper's absolute central concept, gauge time. The idea here is that time isn't part of the territory, reality itself. Nope, it's just a feature of the map that we use to navigate reality. Think of it like a compass on a map. North isn't a fundamental property of the landscape, is it? It's just a convention we use to describe it. This paper asks, what if past and future are just like that? So, this leads us to the intellectual core of the paper, dissolving the mystery. The big claim here is that retrocausality isn't some deep physical puzzle we have to solve, it's an illusion, an artifact created by our perspective. To get how that works, we need a new term, foliation artifact. The paper suggests that reality is a 4D object, but we only experience it in these 3D slices, one moment at a time. A foliation artifact is something that seems real, but only exists because of how we're slicing things up. For example, think about a simple 3D cone. If you slice it horizontally, what do you see? You see a tiny dot, then a growing circle, then a smaller circle. The growing and shrinking aren't real properties of the cone itself. They are artifacts of how you chose to slice it.
And that brings us to a really powerful analogy. We all agree that rightward isn't some fundamental direction of the universe. It's just a direction on the maps we draw. So what if forward in time is exactly the same? A useful convention for sure, but not a fundamental part of reality itself.
This chart really lays out the core distinction. On one side, you have the territory, reality itself, which this paper proposes is a static, four-dimensional block where all events just exist, all at once. Then, on the other side, you have our map, our description, which we create by slicing that block into a sequence of moments. From this viewpoint, causation isn't some force moving through time. It's just us tracing the pre-existing geometric connections inside that 4D block. Okay, so if we accept this new map of reality, what does it do to all those old puzzles? Let's go back to those retrocausal models we talked about and see how this new framework totally reinterprets them. Let's kick things off with the collider bias model from Price and Ward. Their original idea uses a pretty clever statistical argument to explain how a future choice of measurement could seem to affect a particle's state in the past. So, in the old view, a future measurement seems to physically reach back and influence a past event. But in this new geometric interpretation, there is no influence traveling through time at all. Instead, the particle source, its path, the measurement, it's all just parts of a single static 4D object. What looks like an influence is really just a requirement for the whole geometric shape to be consistent. It's one coherent, timeless structure.
All right, next up we've got John Kramer's transactional interpretation. This model's pretty famous for proposing this sort of handshake between a wave that's traveling forward from the past and another one that's traveling backward from the future.
The original model describes this really cool handshake between two waves to complete a quantum event. But in the geometric view, there are no two waves. There's just one single object, a 4D world line connecting the beginning and the end. Those waves moving back and forth, they are simply artifacts. They're what a single 4D line looks like when you try to describe it using our limited, everyday language of 3D and time.
And finally, let's take a look at a computational model that involves causal loops. The original idea here is that maybe a quantum computer gets its amazing power by somehow accessing advanced knowledge of its future solution.
Now, in this geometric view, that advanced knowledge isn't some message sent back from the future. The entire computation, the input, the process, the output, it's all a single timeless 4D structure. The answer doesn't cause the beginning. The whole thing is just geometrically self-consistent from the get-go. That causal loop is just an illusion created when we try to force a sequential, step-by-step story onto an object that isn't sequential at all.
And this brings us to the final, absolutely crucial distinction. What really separates this geometric idea from other theories, even other block universe ideas like eternalism. The paper calls it the gauge deal breaker.
This table shows you exactly where this new idea just breaks from the pack. Look at that first row, time is on tick, which is really just asking, is time a real fundamental part of the universe? Both retrocausal models and even standard eternalism say yes, but this new framework says an emphatic no. That's the deal breaker. For eternalism, time is a real dimension. For this new view, time has no real status at all. It's purely a feature of our description. And that's why, as you can see in the last row, the problem of retrocausality isn't just solved, it's dissolved.
Now, it's really important to be clear about what this means. This framework completely rejects the idea that the future can physically reach back and change the past. That is off the table. But it fully accepts that we can learn things now that change our knowledge of the past. Observing something in the present can absolutely help us infer what must have happened before, just to make the whole geometric picture fit together. It's about updating our map, not changing the territory. And this all leaves us with one final, kind of mind-bending thought to chew on. If our entire experience of time, of past, present, and future, is just an illusion, like a movie projector turning static frames into the appearance of motion, what does reality actually look like when you turn off the projector? What is the nature of the timeless, static, 4D reality that we are a part of? That's the profound shift in perspective this paper leaves us with.